Yeah, so my CPU was overheating on one of my PCs. I'm going to show you how I cooled it. I'll show you how I achieved significant cooling on my PC of about 20 degrees. The contents for this video, I'm going to show you that I was making a video editing PC. I started to have overheating problems with the CPU. I'll show you the solution that I implemented and the results that I achieved. This is my video editing PC at the start. You can see that the fan is over the heatsink in the CPU here, blowing the hot air out the back. There was an SSD on the machine and it sat on top of the DVD drive, and then the RAM was underneath that as well. Yeah, so the specifications for my video editing machine originally were here. It had a 4-thread CPU. I upgraded it to an 8-thread CPU with a higher clock speed. Another notable addition, I added a 4K Blu-ray drive because I'm going to use this PC to rip 4K Blu-rays. Here's a look at me upgrading my video editing machine. Originally I upgraded the machine with a 4K Blu-ray drive, which you can see here was attached here via SATA cable. Then I upgraded the storage to an NVMe drive and upgraded the RAM. I also had an Intel graphics card installed, but it didn't work out for various reasons. So it left me with an underpowered CPU. So that's why I decided to upgrade the CPU, because I needed more power. And you can see here the heatsink and fans laying off to the side. So the problems that I encountered when I was creating my video editing machine, the CPU fan sounded like a jet engine was taking off, so I could tell that the CPU was overheating. When I checked, I could see that it was reaching temperatures of 100 degrees Celsius. After the videos were finished rendering, the CPU temperature would remain in the mid 50s. So these temperatures are way too hot for the CPU, could damage it, and the machine would be worthless. I would expect a maximum temperature of 80 degrees Celsius. How I check my CPU temperatures, I install an application called Hardware Monitor. You can download it from their website here, and the setup button. It allows you to see all the temperatures of the peripherals on your computer. Once you install it, it looks like this here, and you can get the temperatures for your CPU. It gives you the current value and the minimum value, the maximum value. So that's how you check your temperatures for your CPU, and you have to run it with administrator privileges to get all of the values. Yeah, the solution that I implemented for my CPU overheating, so I added the latest CPU thermal paste and a more powerful CPU cooling fan. But this time, instead of blowing the hot air out the back of the case, I was going to cut a hole in the top of the case and blow the hot air out the top of the case. I added a chimney to ensure that the hot air came straight out of the case and didn't linger inside the case. And then I added a cover over the hole to make sure that none dropped inside. Yeah, just a picture of the thermal paste I used to cool my CPU down. You see the thermal paste here, and then I use the applicator to spread the thermal paste onto the CPU. You see, this is a different PC, but you can see how I apply my thermal paste. I spread some thermal paste over the entire CPU using the applicator, a thin layer of it, and then I add a blob of thermal paste in the center. And then, so when I put the heatsink back on to the CPU, I know that the entire CPU is covered with thermal paste, and I don't have to worry if there's any missing areas. Moving on to heatsink decisions. This was the original heatsink that was in the computer. You can see here it's an awkward size, so I couldn't find a third-party heatsink and fan combination to replace it with, so I had to use the stock heatsink. This is the heatsink installed in the computer. You can tell from this point to this point here with the screw positions that It needed a 80mm fan. These are the fans that I used in the computer. This is the original fan, which wasn't good enough. I moved on to a Nokia fan, which was better, but I struggled at the higher temperature, so I needed an even better fan. So I went with an Arctic fan with higher revolutions per minute. These are the fans from the underside. You can see that the Nokia fan, uh, more fan blades than the original, and then the Arctic fan, even more fan blades than the Nokia fan. This was the Nokia fan, 1800 revolutions per minute. There's it in the case, but then I needed to go with this Arctic fan. You see, it was up to 5,000 revolutions per minute, which is a lot more, like near 2.5 times more revolutions per minute. There's the Arctic fan in the case. Equipment that I used to modify the top of the case here. Just had some pieces for drilling the holes. That's an 80mm drill piece for that will go on top of the fan. These here smoothed out the sides of that hole. My chimney that I made using a plastic cover for books, and then the cover for the hole. The modifications that I made to the case to allow the hot air to leave. Here you can see that I used an 80mm drill bit to drill a hole in the top of the case right above where the cooling fan would be. Just an initial fitting here of what it would look like. It wasn't cleaned up yet. And then I put the cover over the hole just to make sure that it was all lined up properly. That's another closer picture. And there's another picture, but I cleaned up the hole a bit, and I painted the case. You see here is a chimney on the back of the top of the case with the fan cover on, and a closer picture. You can see here the idea that the hot air would be blowing out the top of the case, and the hot air wouldn't be able to linger around inside the case. There you can see the top cover of the case actually slides on from the back here. Slides on from the back to the front, and you can see then that the cooling fan blows the hot air through the chimney out the top of the case. And you can see here's yet a better idea of what I was planning here. The cooling fan blows the hot air straight out the chimney out the top of the case. And another picture here just from the side just to see in more detail what it looks like. So the results that I achieved by doing the modifications to my computer, let me just bring this down. The fan's very quiet. The temperatures when rendering videos dropped to from 100 degrees to 74 to 87 degrees, and this led to something that I wasn't expecting, and that now that the processor didn't just stay at 100 degrees all the time, I could actually see that the choice of codec used to render videos would actually alter the temperature that the CPU would run at, so that there was something I didn't expect. The temperatures when the PC was idling would stay at the low 30s, so that was good. There's a turbo in the BIOS of this machine, but it was still had 100 degrees when you turn it on, so that there's not an option. And I realized that the next time I make a video render machine, I need to check that if the CPU has heating problems, and I need to have a motherboard that has better CPU options, and the next editing PC needs to have proper cooling. You can see here, just on a quick Google search about the processor that I used, you can see here the top of some of the top 6 entries. You can see that there's heating problems with this CPU. So I'm not the only person that had problems with this CPU. The temperatures that I achieved. You can see here. You can see here using different codecs. You can see here some of them were just too hot, and reds there was these here codecs were too hot. the codec that I'm going to use is this here one, libx 264. You can see it at a maximum temperature of 80 degrees, but it had the lowest rendering time. So even though that's the top end of my heat tolerances, I'm going to use this codec to render my videos with. I'll finish the video off with pictures of the modifications that I made